Hello! So, we've made it. Final question of the paper. We're given 3 points, A, B and C, and we're told that those points represent vertices in a right angle triangle. We're also told that angle ABC is the right angle. So let's just pause. Angle ABC. There's a few ways that you can think about it, but the easiest way to think about it, in my view, is just saying, right, the middle letter, that's the angle I'm interested in. So in other words, B, okay, is the right angle. So 6, 5, that's the right angle. Now also, what we can say is, we'll come back to the rest of the question in just a second. What we can say immediately is, we've been given all this information, but we haven't actually been given a diagram, which kind of the natural progression of what to do next is to draw that diagram so we can actually visualize what's going on. So here we go. This is just a very quick thing, and if you're sitting there in the exam, don't spend ages drawing it out, for goodness sake. Just literally get it down on paper, do a quick sketch, and that's it, okay? So let's just very quickly put my points on. So I'm going to have point A at -2, 1, so -2, 1. That's going to be where point A is. I'm going to have my point B at 6, 5, so 6 across, 5 up. It's going to be somewhere about there. Okay, this is just to literally get a feel for the question, and I'm going to have my point C. Well, my C is given as 4K. I'm not being actually given a Y value of my point C. So all I know is that my C will lie somewhere along this line, because this line represents everywhere where my X coordinate is 4. Okay, but I don't actually know how high or low on this line my point C falls. Okay, and I've also been told that, you know, these vertices represent a right angle triangle. I don't know where C is at the moment, so let's try and draw some things in. So first things first, I'm going to connect A and, I'm going to connect A and B together, okay? And I'm also told, look at the question, I'm told that angle ABC is the right angle. I've established that's my point B. That's my right angle. So in other words, I know that a right angle is going to fall there. Well, I know then that either my line is going to come off like that, or my line is going to come off like that. But look at where my line intersects my C. If you look at this one, for example, this line below the axis, below the B, sorry, sort of going down, it's clearly not going to intercept that line which I drew, which C can fall on, right? So it's clearly not going to intercept this dotted line, which I know that C must fall somewhere along this line. So therefore, I know it must be the one above the line, because that does cross the that line which I'm after. So I know that C is going to be up there somewhere. Okay, and then I can finally form my last line in like that. Okay, and there is my right angle triangle. Okay. So let's read the rest of the question. Find an equation of the line that passes through A and C. Well, my line that passes through A and C, you can clearly see is the yellow one. Okay, so my yellow one, this is the equation which I'm after. Okay, and this is just a form to give my answer in. Now, before I go any further, I need to remind myself of a few things. So, let's suppose I have my straight line like this. This is a different line now, but I just want to get the idea in my head. So let's suppose I have a straight line like this, and I've been given 2 points, only 2 points on this line. Can I work out the gradient? Well, what is the gradient again? Gradient is just a measure of steepness, right? So the formal mathematical definition is just simply saying, right, for every unit that I move across, how many do I move up? Okay, and fairly obviously, for every unit that I move across, if I move, say, 1 unit across and 6 up, that's going to be steeper than moving 1 unit across and 0.2 up. Okay, so, you know, hopefully you can visualize that. So the way which I define it, normally we give the letter M to define gradient. And if you remember, y equals mx plus c, the M stands for the gradient. Okay, and it's just literally rise over run. So my change in y over my change in x. Okay, this triangle here just simply means change. Short way of writing change. But if you want to write change out, go for it. Right, so I've got change in y over change in x. So what is my change in y? Well, my change in y is just simply, I'm starting at my point N, which has a y coordinate of 3, and I'm moving to my point P, which has a y coordinate of 7. So are you happy then that the difference between 7 and 3 I can write like this? It's just going to be 7 take away 3. Remember, right back at primary school, difference just simply means how many, how many between those two values. Okay, and the way which I can represent that is as a negative, as a take away. Okay, so what's my change in x? Well, I'm starting at my n, which has a coordinate, x coordinate of 2, and I'm moving across to my P, which has an x coordinate of 4. So you're happy then, the difference between 2 and 4 can be represented like this, so 4 minus 2. Okay, so if I then calculate that, so 7 minus 3 is 4, and 4 minus 2 is 2, okay? And hopefully now, if we just pause very quickly, hopefully now you can see why we divide by this value here, okay? Why we divide by the 2, because if I just wanted to move 1 unit across, okay, it would be, so if I just calculate this very quickly, so 4 divided by 2 is 2. So all this is basically saying is that for every unit I move across, how many do I move up? Because this is, I move 4 up if I move 2 units across, but I only want 1, so I have to divide by my 2 to sort of, here I'm moving 2 units across, okay? I only want to move 1 across, so I'm going to have to find half of that distance, which is why then I divide by 2. Hopefully you can see. So my gradient of this orange line here is 2. So now let's look and see another line which lies perpendicular to the line which we just looked at. So remember what perpendicular means? It means at 90 degrees to. So you can see that this purple line here is the perpendicular line which I'm looking at. Okay, so I've been again given 2 points that I know lie on this line. So let's just try and work out the gradient. So maybe if we call, maybe if we call the orange line M1, my gradient 1, okay, and this one is sort of M2, my purple line, okay. Remember what it was, same thing again, change in Y over change in X. So what's my change in Y? Well, I'm going from M to Q, right? So I start at 3 and I go to 2. Right, because my y coordinate of m is 3 and my y coordinate of q is 2. So it's going to be 3 minus 2 on the numerator. That's my change in y. What about my change in x? Well, I'm going from m to q again. So my x coordinate of m is 1 and my x coordinate of q is 3. So it's 1 minus 3. Okay, so 3 minus 2 over 1 minus 3. 3 minus 2 is 1. Okay, 1 minus 3, that's negative 2, right? So I'm just going to stick the negative out the front actually. So it's negative 1 over 2. Okay, so it's negative a half. Okay. Now look what happens if I multiply these two things together. So if I multiply m1 by m2, okay, look what I end up with. So I end up with 2, which was my gradient of m1, okay, then I'm multiplying that by m2, which is my gradient of negative a half, okay, look what I get. It's going to be negative, sticks out the front. So what's 2 times a half? 2 times a half is just 1, right? So it's going to be negative 1. And this is true for any, two lines that are perpendicular to each other. The two gradients, when they multiply together, should come out as minus 1. Okay, so another way which we can write that is that m1, so I've got m1 times m2 up here, m1 times m2. If I just rearrange that, I can say that m1 is just equal to negative 1 divided by m2, okay? And this is sometimes called the negative reciprocal, okay? The negative reciprocal. Reciprocal just means 1 over, the reciprocal if you like, so you flip it, so it becomes 1 over. That's how I get that. Then I just stick a negative out the front, okay? So basically two lines that are perpendicular should have gradients that are negative reciprocals of each other. Now, one final formula. I promise it's the final one, then we'll get back to the question. Okay, but it is useful for the question anyway. So let's suppose now I have this line, and I'm given 2 points in this line, or specifically 1 point that I know the coordinates of. So I've just enabled that x1 and y1. So this is the point that I know the coordinates of. Okay, and then this green point here is any other point in the line, any other point. So how do I work out the gradient of that line? Well, my gradient, so m, okay, is going to be equal to my change in y. My change in y over my change in x. Well, what's my change in y? Okay, so I'm going from this coordinate to this coordinate here. So I can just take, it doesn't matter, I can do it around the other way. So I can easily just take this y value and this y value here. So let's say y minus y1. That's just my change in y. Okay, I'm literally just saying, right, this value, take away this value here. Okay, but then I need to do the same for my change in x. So I need to take this value, take away this value here. So I end up with x minus x1. Okay, let me just do a little bit of rearrangement. So I've got my gradient is equal to y minus y1 over x minus x1. Okay, so if I just rearrange, then I can just simply say that y minus y1, so if I multiply through by this denominator, so y minus y1 is equal to m times, well, if I times by this on both sides, and I end up with x minus x1. Okay, and this is a very, very important formula. So 3 ideas. First of all, my gradient is given by change in y over change in x. Second idea is that if I've got gradients of two perpendicular lines, then I can just say that one gradient is going to be the negative reciprocal of the other. And then my final formula is y minus y1 equals m times x minus x1. And this will give me my formula of any straight line, given that I know the gradient, and any 2 points, so x1 and y1. So coming back to my diagram now then, I want to first of all, I want to find the gradient of this line, or I want to find the equation of this yellow line, okay? But in order to do that, I need to use the other lines to find that, okay? Because first of all, I need to know what C is before I do anything, but I can use my newfound knowledge to find that. So let's first of all start by finding the equation of this line, or more specifically the gradient of this line, because this purple line lies perpendicular to that orange line. Okay, so if I'm able to find the gradient of the purple line, then I'm able to find that. Okay, but first of all, I need to find the gradient of my orange line. So my gradient of my orange line will be given by, so my gradient of orange line, let's call it M1, is going to be given by my change in y. So my change in y over my change in x. So what's my change in y? Well, my change in y is going from 5 to 1, so it's 5 minus 1. Okay, and my change in x is going from 6 to minus 2, so it's going to be 6 take away negative 2. Careful of the double negative, that just becomes a positive. Okay, so I've got 5 minus 1, which is 4, over 6 minus 2, which is 8, which comes out as a half. Now, because the gradient of my purple line must lie perpendicular to my orange line, this is what this perpendicular sign means. I'm told that in the question, all right? So therefore, I'm going to have to find out the gradient of my second line. Well, it's just going to be the negative reciprocal of that line. So it's going to be negative 1 over my orange line. Negative 1 over my orange line. So I'm going to have, that's equal to negative 1 over, and I'm going to write that actually as 1 divided by, because remember, just over just means divided by. Then that gradient is my orange line. So my M1 is a half, okay? Remember what I do when I deal with dividing by fractions, okay? I have to flip this second one. So flip it becomes 2 over 1, or just 2, and this just becomes a times. So I end up with negative 1 times 2, which just comes out as negative 2. Okay, so the gradient of my second line, my purple line in here, is negative 2. Now using that, can I then work out what my y coordinate of C is? Well, yes, I can, because I know that my gradient of my second line will just be given by change in y over change in x. So what can my change in y be? Well, my change in y will just be k minus 5. You happy? Because those 2 points lie on my purple line. They lie on my purple line. So if I just wanted to use those 2 points to find out my gradient, so let's suppose I don't know my gradient, how would I find it out? Well, I'd use the y coordinate of C, which is k, minus my y coordinate of B, which is 5. It's just my change in y, okay? Divided by my change in x. Well, my change in x is going from 4 to 6, so it's 4 take away 6, right? Okay, but I know that that must be equal to negative 2. That must be equal to negative 2. So let's just solve that very quickly. So I end up with k minus 5. I can't do much with that. Over 4 minus 6. Well, that's negative 2. And that must be equal to negative 2. So if I just multiply through by negative 2, right? Multiply through by negative 2. That comes out as 4. Okay, then if I just take away 5, so I've got k minus 5. I don't want k minus 5. I just want k on its own. So I add 5 to both sides. That then becomes 9. So I know immediately then that my point C must be, k is 9. So my point C must be 4, 9, because I've just worked out that k is 9. Okay, cool. Now I can use all that information to find out what that line is there. So this is where I'm actually going to use my y minus y1 equals m times x minus x1. All right. So do I know my gradient at the moment? No, I don't. So I need to work out my gradient first. So my gradient, just change in y over change in x. All right. So what's my change in y? Well, I'm going from 9 to 1. So it's going to be 9 take away 1. 9 take away 1. Over my change in x. Well, I'm going from 4 to negative 2. So it's going to be 4 take away negative 2. Careful of the double negative. That just becomes a positive. Let's work that out. That comes out as 9 minus 1, which is 8, over 4 plus 2, which is 6. Can I cancel that down? Yeah, I can. It comes out as 4/3. All right, so that's my gradient, 4/3. Okay, and then I just use my y minus y1 equals m times x minus x1. So what's my y1 and y2? What's my x1 and y1? Well, I just simply choose one of these two values that lie on my orange line. So I can either choose C or I can choose A. So I'm going to choose C just purely because it doesn't have any negatives in. Okay, so let's choose C. So I'm going to have y minus my sorry, that's y minus my y1. So let me just write out c. So c is 4, 9. Okay, so that means that my x1 and my y1 is going to be, so my x1 is going to be 4 and my y1 is going to be 9. So it's y minus y1, so my y1 is 9, okay, and that equals my gradient, which is 4/3, times my x minus x1. So times x minus x1. What was x1 again? It was 4. Okay, and then it's just a case of solving that equation or rearranging that equation to get it in the form. AY plus BX equals C. Okay, so I have to have integers. So I'm looking at that equation. I'm immediately thinking, I've got a fraction here. Don't like the look of fractions. So all I'm just going to do is I'm going to multiply both sides by 3 to get rid of that denominator. So if I multiply both sides by 3, okay, what I'll end up with is 3 lots of y minus 9. Okay, and that's got to be equal to, well, if I multiply this right-hand side by 3, are you happy I'm just going to have 4/3 times 3, which just comes out as 4. Okay, that's the whole point of multiplying 3 by 3, times x minus 4 still on the right-hand side. I haven't done anything to that. I've just simply changed that fraction. Okay, so let's just try and rearrange this now. I appreciate that I'm sort of writing over the lines, but there we go. So let's expand this left-hand bracket out. So I'll end up with 3 times y, okay, minus what's 3 times 9? 3 times 9, that's going to be 27, right? 27, okay, and then that's going to be equal to 4, let's expand the right-hand side brackets out, so I'll end up with 4x minus 16, okay, and then it's just a case of rearranging that, okay, so I'll end up with, I'll just write it down underneath the, you know, to sort of make sure it's clear, so 3y, let's get all of, so remember what form I have to get it in. I have to get it with the y's and the x's on one side and any numbers on the right-hand side. So 3y, let's take the 4x over to the other side. Still got 9 is 27, and that's still equal to negative 16, okay? And let's now take the 27 over the other side, so that's going to become a positive 27. So let's have a look at this. I'll end up with 3y minus 4x equals, well, what's 27 take away 16? That's the same thing, right? It's going to be equal to 11. And that is your final answer. So I appreciate I've gone through that rather quickly, but hopefully if you understood what I was saying at the beginning of the video, okay, with sort of the gradients and, you know, the gradients of perpendicular lines and negative reciprocals and how to work out the equation of a line, then all I'm doing here is just simply applying all that knowledge. Okay, so I've gone through it slightly quickly, but feel free to go through, pause the video, and sort of just to remind yourself exactly, to make sure you know exactly what I'm doing. But that's it, I'm finished the paper.